All right, let's look at these last couple of questions related to the graph that we just made. So in part D, it's saying use the graph from the previous page to solve 6 equals P of Y. So that means, again, that since we are looking at P of Y equals this, so that means that, we got green, that our output is P of Y equals that. So we're looking for the output. So we want to know when the output is 6. So if this is 5, 6 is approximately maybe just under that. And so I want to find out where that intersection is. So I'm going to look down. And I don't know, mine looks to be, if that's 100, these are each counting by 10, so that's probably 109. And again, it just depends on how you might have filled in that graph. So we know that P, which is our output variable, and inside the parentheses is the answer of the input. In this case, I'm guessing mine's about 109, and that equals the value of 6 or 6%. So now we want to solve using Desmos, and so we have the function in Desmos. I'm going to retype it so that we have, again, P, and we have to use the X. So P of X equals, and then be careful typing this in because this first term has quite a few zeros in it, and I want to raise that to the third power. And again, I'm using X as my input variable. And then I'm going to square that term, and then so here's our function. We created a table last time, and those values, we had 0, and then we had 30, 48, 66, 77, and 84. And again, we see this little zoom fit or zoom the table. So I'm going to click on that so I get this nice picture of what's going on. And I want to find out when y is equal to, or the output, excuse me, is equal to 6. So that means in our next line, in line 3, we're going to do y equals 6. And Desmos graphs the line y equals 6. And we end up with the answer of the input value of 103.15. So let's go back and mark that down. So what did we do? Because it always says what was done in Desmos. So we want to state that in line 3, we did y equals 6. And then it's asking us to round to the nearest hundredth and to also write this in function notation. Oops, I got to go back. P of, and we had 103.15. I need to go back and look at part D because it actually said answered is an ordered pair. So I need to change that. So here is function notation. And ordered pair notation for part D, we want to say 109 or whatever you found it to be. So we want 109, comma, and then the output was 6. Oops, my colors are not working. There we go. Get rid of that one. And 6. There we go. All right, so now we also want to know what the horizontal intercept, using point of intersection, but we really don't need to what we call point of intersection because we're just looking for where this graph intersects the horizontal axes. And so it intersects, and we just tap on where we see that horizontal intersection or the horizontal intercept. And so we end up with 106.01 if we round. So let's see. So we're going to state that, so we just tap on horizontal intercept. That gives it to us. We know that a horizontal intercept is a point, so we want to state that this was 106.01, comma, and then the output, because it's a horizontal intercept, is always 0. And we need to state what it means. So after 106.1 years since, or you can just start with 106 cents. And again, we're talking about years after 1930. The percentage of women aged, as our output is the women who are age 65 or older, living alone. Well, 106 in 1930. So let's see, is this a was statement? So 106 plus 1930 means we're in the year 2026. So this is what's going to happen. So we want to say living alone will be 0%. And so if that statement makes sense, so do we think that there would be women living alone, that would be 0%? Probably not. So that's going to indicate our that we need a change in our practical domain. So again, our practical domain is the years since. And we can say we're going to go from 0 year all the way up to, because again, years can be broken into parts, so we're going to use inequalities, all the way up to, but not including 106.01 years. And this is not included because it is the practical, well, let me write it this way rather than saying the practical range. Let's just say that 0% is not possible. We can come close to that, but it's not possible. So in our range, which is our percentage, we know that our practical range, and let me identify our practical domain. So our practical domain, and now our practical range, we can come close to, but never really reaching 0%. So that's why we're not going to use an or equal to there. P, or you can write P of Y, is less than or equal to. Now we got to figure out what the max percentage is. So we know it's up here at the top someplace. So we're going to use Desmos. And if you click on our graph, you'll see a very faint point, and that is our maximum point there. Desmos will help us find all the important points. You'll see also a faint point on the vertical intercept, a faint point on the horizontal intercept. So we know that this is an input of 66.57, an output of 38.34. And remember, we're talking about the output, so the percentage. So we want this to be 0 is less than or equal to P, which is less than or equal to 38.34. And that would conclude our problem.